and welcome back to another lesson in chemistry. Today we're going to be talking about atomic mass. We want to talk about the atomic mass of an element today. Atomic mass is a relative mass. Now, as it turns out, everything really is relative mass. What that means is that we determine the mass relative to some standard. And so when we talk about something having a mass of 3.5 kilograms, that's relative to the standard kilogram. With atoms, a kilogram is much too large a standard to use. And so what they decided upon was the atomic mass unit, which can be abbreviated either as AMU or just simply U. And an atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. And so all atomic masses are expressed relative to a carbon-12 atom. That doesn't tell us right offhand what it is compared to a kilogram. We can figure what that is later, but this is talking at the atomic level where kilograms are going to be much too large, and so we use atomic mass units. Now, the other thing we have to take into account is that when we talk about an element, it's made up of several different types of isotopes, and each of those isotopes contributes to the overall mass of the element. And so the atomic mass is also a weighted average. It's a weighted average of the different isotopes that go into it. So if we look at our table of isotopes, we can see, as I pointed out before, that calcium has 6 different isotopes, and each of them has a different mass in atomic mass units. This last column is their relative abundance, how frequently they occur in nature. And so if we were to take 100 grams of calcium, we would find that 96.941 of those grams were made up of calcium 40, and that 0.647 grams would be made up of calcium 42, and 0.135 of calcium 43, 2.086 of calcium 44, calcium 46, Calcium 46 represents 4/1000ths of a gram, and calcium 48 would come in at 0.187 grams. Each of these contributes to the overall mass. And if we look at our periodic table, we can see that calcium over here has a mass of 40.08 atomic mass units. It is closest to the mass of the isotope that is in greatest abundance. That's the one that contributes the most mass to it, and so when you average it, you get an atomic mass very close to the one that's in greatest abundance. So let's consider neon. It has 3 isotopes. We have their masses and their relative abundance. So if we take their isotopic mass and multiply it by their relative abundance, 0.9048. I've changed it from percentages into a decimal form. And then for neon 21, it's going to be 0.0027. And then for neon 22, it's going to be 0.0925. And when we multiply these out, we get, for neon 20, we get 18.089 and we only have 4 significant figures here. So we'll need to round this up, so that's going to be equal to 18.09. This comes out to 0.05668. Actually, this only has 2 significant figures in it, so we need to round this to 2 significant figures. So we're going to get 0.057. And then lastly, we get 2.034. Only 3 significant digits here, so we have to round this to 3 significant digits. So that's going to be 0.23. And then when we add those together, and so when we round that, we come up with 20.18, because we need to round to the hundredths place, atomic mass units. And if we compare that to our entry on the periodic table, we find that they have neon has 20.18 atomic mass units. So we took the isotopic mass, multiplied it by the relative frequency, relative abundance, added those figures together, rounded to the proper number of significant figures, and this is the atomic mass for the element. It's also sometimes called the average atomic mass. That's it for today's lesson. Until next time, goodbye.